All right, so this is using Amazon's web services from Ruby, and get the question: does it scale? Well, when I was thinking about that, and why you would use Amazon's web services at all is to really help solve scaling problems. Being able to, with their services, they handle basically the problem of being able to scale your applications. But with Ruby, you need to know the ability to how that works. So when I was thinking about that, I thought, there's this I Love Lucy episode that basically, to me, is a perfect example of needing to scale. And so I'm just going to play a couple-minute clip of the episode there. And it's the Chocolate Factory episode.
This is the wrapping department.
Yes, ma'am.
Now, the candy will pass by on this conveyor belt and continue into the next room where the girls will pack it. Now, your job is to take each piece of candy and wrap it in one of these papers and then put it back on the belt. You understand?
Yes, sir. Yes, ma'am.
Let her roll! Let her roll! Well, wait here. Somebody's asleep at the switch.
What are you doing up here? I thought you were downstairs boxing chocolates.
Oh, they kicked me out of there fast.
Why?
I kept pinching them to see what kind they were. This is the fourth department I've been in.
Oh, I didn't do so well either.
No.
All right, girls. Now, this is your last chance. If one piece of candy gets past you and into the packing room unwrapped, you're fired.
Yes, ma'am.
Let her roll!
Oh, this is easier. Yeah, we can handle this okay. Listen, Ethel, I think we're fighting a losing game. Here she comes.
Fine, you're doing splendidly. Speed it up a little!
All right, so clearly that's a question of does it scale? And in that case, it did not. But, oftentimes we don't have the opportunity to just eat all the chocolate, right? So we've got to be able to figure out how to handle this. And so Amazon Web Services can help us do that. Yeah. Oh, thanks. That was it. But would have been useful to know beforehand. But thank you. So the Amazon Web Services that I wanted to talk about in particular are the SQS Simple Queue Service, the EC2 Elastic Compute Cloud, the S3 Simple Storage Service, and the Simple DB. The two that I'm going to really kind of be showing the Ruby code for are the SQS and the EC2, mostly because the API is similar on accessing any of those services with the particular Ruby code that I'm using. So I'll be showing the SQS and EC2. The Ruby gems that I'll be using are the Write AWS Ruby gem from Write Scale. There's a lot of different Ruby libraries out there for communicating with Amazon's web services, S3 libraries and SQS libraries and EC2 libraries. What I like about the Write Scale gems in particular are that they, in the single gem, support all of the different services I just mentioned with the SQS, EC2, S3, and SimpleDB. So in addition, it's a well-maintained library. They update it often. Amazon updates their web services, it seems like quarterly. So the Write Scale guys seem to be on top of that and always release new updates for whatever new features are coming out. As well as they've got a robust HTTP library where Amazon occasionally will throw you error conditions and things like that that you can retry. And so their HTTP library will automatically retry that for you so that you don't have to have as much error handling in your code to handle those types of instances. The other library I want to mention is, it's called Cato. It's an EC2 pool manager, and it's basically a port of the Lifeguard Java library that I wrote. I didn't write the Java library, I wrote the Cato port of that, and I'll be using that today. So using the Write Scale gems, we're going to just show the Write AWS SQS. So you just require your gems, and then the Write Scale gems can use, because Amazon's web services communicate via XML, you have the ability to, with the Write Scale gems, specify that it uses the libxml library, and that speeds up performance quite a bit rather than just using rexml, which it'll default to if you don't have libxml installed. So here we're just basically setting the parameters that are required to connect to SQS. So Amazon gives you an access ID and an access key. And really those are the only two parameters that you need to specify if you're going to be communicating directly with Amazon, because it'll default to communicating with them. But optionally you can specify the server, the port, and the protocol. And that's really handy for doing local development where you may not want to talk directly to Amazon, or if you're doing a presentation like this, where I don't really want to be communicating with Amazon right now because the internet connection may not be working. So SQS queuing. So to create a queue or to get hold of an existing queue, you basically just call sqs.queue and whatever the name of your queue is. When you have a reference to that queue, you basically just call push to put a message in the queue. And again, this is Write Scale specific. Other libraries may do that. In the most recent update to SQS, they changed the maximum message size from 256K to 8K. And so you don't really want to be using this for pushing large messages into the queue and pulling them out, because it's not really designed for that. So typically what you'll do is you'll put in some sort of identifier that you can look up in the database, or maybe a file name or something like that that you can look up on S3 and get your additional information that you could have put in the message. To get the number of messages in your queue, you just call queue.size, and it'll give you basically an approximate number of messages that are in their queue. The reason why it's approximate is because of the way that Amazon has their clusters set up, that when you add messages to the queue and you call back out of it, it may not go onto the same servers in their cluster, and so it's basically just an approximate size of what their best guess is to what the number of messages you have in there. To get a message out of the queue, you just call queue.receive, and if there are no messages in the queue, it'll just return nil. If there's a message in the queue, obviously it'll return it sometimes. Even if you put a message in the queue, because again, how the clustering on Amazon's services work, you may not actually get that message right back out, because where you put it may not be exactly where it's pulling from when you call it receive. So it's just something to keep in mind, that it's not always guaranteed that you'll be receiving messages all the time, even though you know you put one in there. So to access the what the message is, you just call body on it, and that returns the body. To delete the message out of the queue, you call delete. The messages by default, when you call receive on them, there's a visibility timeout that you can also specify, where the message will not be visible to other receive calls until that timeout expires. So for instance, if you've got a process that calls receive on the message, but then never deletes it, after that timeout expires, that message will now be visible again, so that if you did call receive, that message could come back out again. So that's the queuing. Feel free to ask any questions at any time. So using the EC2 write scale gems is pretty much like using the SQS gem. As you specify your access ID, your access key, and optionally the server port and protocol. Basically, all the write scale gems to connect to the Amazon services connect exactly like this. So whether you're doing S3, EC2, SQS, or simple DB. So it makes it, the API is kind of really nice that way. So communicating with the EC2 instances, if you're not familiar with EC2, they're basically virtual servers where Amazon stores a copy of a machine instance that you can basically boot up as many of those copies as you want. And boot up time is on average around 2 minutes, though I've seen it go quite a bit faster recently. There are different size images that you can boot up as far as the kinds of hardware, virtual hardware, if you will, that gives you more memory or more processors, and they charge accordingly. So to describe what kind of instances that you have booted up, you just call it EC2 describe instances, and it basically returns you a hash that is then other hashes of information regarding the uptime on the machine, what the IP addresses are, those sorts of things. To run an instance, you basically call run instances whatever the name of the Amazon machine image is, what the minimum number of instances you want and the maximum number of instances. Now you may not actually get the number of instances that you request, so it's a good thing to check to see, hey, I requested, start up 5 instances. It may have only started up 3. To terminate an instance, as part of that hash that you get with a describe instance, or the run instance will also return the same type of information. You basically get an identifier that you can use to then later terminate those instances, and it basically just takes an array to do that. So Cato, the pool manager, basically what I wanted to be able to do in scaling an application is basically dynamically determine, should I start an instance up or should I close one down if they're just sitting there idle? And so I did a lot of searching and stuff like that and tried some code on my own, but ultimately I found a Java library called Lifeguard with some pretty good documentation on it basically solving that exact same problem. And so I basically ported that over to Ruby, and that's what Cato the Pool Manager does, is it basically looks at your queues, determines whether or not it should start up or stop instances, and then it relies on the write scale gems for basically running those things that you just saw with the queuing and the receiving messages and those sorts of things. So I'll talk about the config in just the next one. So you can manage multiple pools of EC2 instances. So let's say you have 2 different machine images. You have a machine image for your website, or you have a machine image for your database or some other kind of processing servers, application servers, or things like that. You can use Cato to manage those multiple pools independently. So let's say your application servers are just getting hammered. Well, it can manage starting those up while leaving your web servers, just running normal, or vice versa. So you can specify the minimum number of instances you want running, the maximum number of instances. You could specify ramp up and ramp down intervals so that it can monitor the load. And if it sees that you're getting just a huge amount of load in your queue, it can basically ramp that up a lot faster than if it sees that you're just incrementally, the load is increasing. It can do that a little bit slower so that it's not starting up so many instances. Same thing with shutting down. So if suddenly your queue gets emptied, all your processes do all the work. basically it can ramp down slowly or it can ramp down pretty quickly. There's also, you can specify with Amazon, they charge you for the full hour of each service that you have, of each instance that you have running. So if you're only using that instance for a couple minutes to do some processing, it doesn't really make sense to shut that instance down as soon as it's done processing, because Amazon's just going to charge you for the full hour anyway. So you can specify what the minimum time that your instance is running. So probably I would think that you could set it at 55 minutes or something like that, unless you had a reason to set it shorter. Yeah.
So all the caveats that you're applying about Amazon seem disturbing.
Yeah. Well, there's definitely things that you have to consider in deploying to Amazon. It's not, this utopian deployment environment where, everything just is going to be rosy for you. You basically, it's just not perfect. And so you have to account for these sorts of things if you're going to be using Amazon's web services.
Like you ask for an instance, you may not get one.
Yeah. I'm not sure like real world kind of statistics on how often that happens. In my personal experience, not with EC2 but with SQS, I've had a lot of different issues with working around those sorts of things where I'll put a message in the queue. I know it's in the queue, but I call receive message and I don't get anything back. But 10 minutes later, hey, there's my message, So it's, like I said, it's not perfect, but, it's not totally horrible either. Cool. So I wanted to actually put together a sample application that actually demonstrates this and actually uses this, and not just talk about what the code can do, but I actually wanted to show code actually running and working. And so I thought, back to that I Love Lucy episode, I thought, that's a really kind of cool way of illustrating, the ability to need to scale. But the problem is they couldn't just dynamically add and remove people as they needed. But with Ruby, we can. And I wanted to put a little bit of a Ruby twist on that. So rather than making chocolate, we can make chunky bacon. So I've got a little workflow here, little flow chart of the process of making bacon. So we start out with slicing, we call a package on a slice of bacon, and basically what happens is it gets added to the database so that we have a record of that. It also gets added to the chunky unpackaged queue. Now we have Cato, the EC2 pool manager, sitting over there off the side monitoring that chunky unpackaged queue. And we also have the cartoon foxes there. Those represent, each one of those represents our EC2 instances that are running. So what Cato does is it monitors the chunky unpackaged queue to see, do we have any bacon in there and how much? And it looks into the chunky unpackaged status queue where the EC2 instances basically report, am I busy or am I idle? Am I really doing something, or if I'm just sitting here? And that way the pool manager can know, well, hey, they're really busy and there's a lot of stuff in the queue, start up more. Or, they're just sitting there idle, not doing anything, shut them down. Once the instance is started up, it starts pulling those messages from the queue and it starts packaging them up. Once a slice of bacon has been packaged up, it gets put into the chunky packaged queue. Well, we have another process that's sitting there that's basically just doing nothing but pulling the slices out of the packaged queue and just updating the database that, hey, this slice has been packaged. So we'll just take a look at that code, which again uses the right scale gems for that to kind of give an example of how this process is working. I basically just have a SQL model for this, and so it goes into calls create, which creates the entry into the database. I get a reference to the chunky unpackaged queue. I push the ID of the slice that was created in the database onto the queue, and then I just return the slice. So the foxes, they sit there, and while they have, while packing, they basically attempt to pull a message out of the queue. They send that status update that I was talking about, that, hey, it's now busy doing something, And then basically all this does is it doesn't really do any work, but it basically just puts that message body back onto the packaged queue, and then deletes that original message. So basically, when we added the message to the queue, we just put the ID of the slice in there. And so basically, the body, it contains that ID, and we just push that back onto the packaged queue. We send the status update that, hey, you know, I'm not busy doing anything anymore, and then it just waits a couple seconds. The Fox get packaged bacon basically does the kind of same sort of thing where it gets a reference to the packaged queue, goes and it pulls a message out of that queue. Also have it do a check to make sure it actually exists in the database in case it didn't for some reason. And then it just updates the package that time with what it is. And then it just deletes the original message out of the queue. So, yeah. How often does the delete message? I'm not sure, but I wouldn't be surprised if it did. And so you should probably account for that in your code. I've had instances of the messages actually being delivered twice. And so that's very possible that that you attempt, because it gets delivered twice with the same message ID. And so your first time it gets out of there, it gets deleted. But in somewhere in Amazon's cluster, somehow a duplicate of that exact same message is floating around. And so if you attempt to operate on that, it basically fails. So yeah, again, the question earlier about the question here was how often, or is it possible if when you call message delete, if that would generate it could generate an error, and yeah, it totally could. Good. All right. Cool. All right. So we've got our chunky bacon application here, and it looks similar to the chocolate factory that we had in the I Love Lucy episode. And so we've got our cartoon foxes to help us out here and package up this bacon. And so each one of these foxes represents an EC2 instance that's running. Now, because I mentioned before, it's not, it wouldn't have been wise to actually try to rely on really connecting to Amazon to do this. I've basically emulated EC2 and SQS locally here on my machine so that when I do API calls to the write scale gems, it's basically going to my emulated processes rather than going really out to Amazon. So let's get some let her roll, let her roll, and so we'll let her roll here. So I'm just going to loop and slice some bacon here. And so let's see. Come on. Here we go. So the bacon's going down the conveyor belt, right? And so it's being packaged up. As we can see, it's being transformed there. And we can let this go for a while, but I know that, it'll probably be fine. So let's, speed her up a bit. So let's go ahead and do that. So I basically just doubled the speed on that from, basically it was doing every 3 seconds it would go and do a slice, and so now every 1.5 seconds it's creating a slice. So that's, we can see that it's getting down the belt, pretty good. But the way that I have things configured, it considered the load to be enough to go ahead and start up another Fox, which it did. And so it's still going down pretty good. Hey, get another Fox, all right. So basically it's monitoring that queue that we're putting the slices into, the Cato process that I have. It's monitoring the queue, and it's saying the instances are reporting whether they're idle or busy, and the queue's taking that into account, or the EC2 pool manager is taking that into account and starting and stopping Foxes as needed. Because of this I'm pretty much trying to do this in real time, and your Amazon instances aren't going to start up in seconds. It's going to take a couple minutes, so it's not exactly perfect here, but it works okay. So let's just really kick this up. There we go. You can see that it's not actually getting to all the slices. As each slice goes down the conveyor belt, I'm basically doing an AJAX call to say, hey, give me the status. Oh, hey, there's Darth Vader in a sombrero. Right on. Right on. So, as each slice is coming down the conveyor belt, it's doing an AJAX call every 1.x seconds or whatever to say, hey, am I packaged yet? Am I packaged yet? Am I packaged yet? And we don't have enough instances. I basically set the minimum instances at 2, as we saw when we started up the app. The 2 were there, and it'll basically just cap it at 6. So, are there any questions at all? So I've got some time. Yeah.
The queuing service, question is just a little bit of the value of why you use something like that, especially if you're not really sure if you receive if that is the next one. What would you use that for? Do you have an example?
Sure. I have a service that I have that basically processes continuous integrations in an automated fashion. And so when somebody makes a commit to the repository, basically it records in the database that, hey, I have got this new commit in there and it needs to run continuous integrations on there. So I can use Amazon's EC2 service and SQS service to basically go and fire up processes if I need to go and run those builds. And so in my particular case, I don't really care what the message order is, or what order I receive the messages in, because it's just not critical to the way the application works. And so for those types of things, it works fine. Sorry, to repeat the question, what was the phrase that you used?
The application, but so is the benefit of the queuing service being at Amazon that you can start as many instances as you want, they can all access that same queue?
Okay, yeah, so what's the benefit of using Amazon's queue service as maybe opposed to just using your own queue on your own servers or something like that? The benefit that I found to that, because I was using my own queue, was that I can, rather than managing my own queues and opening up my own ports and adding my own security and those sorts of things, I can just have Amazon basically manage that for me. And the service is so cheap that, cost-wise, it doesn't really cost me a whole lot to do that. And I, address the reliability kind of issue where, in my particular case, doesn't really matter all that much if the message doesn't come right away or it doesn't come in order. And so basically using Amazon's queue services for that would be great. There's a lot of new queue things, queue services kind of popping up that you can run on your own servers. And if they manage authentication and they manage that sort of thing, then by all means, that would definitely be a good benefit. But I just didn't want to kind of have to reinvent the wheel to do all that.
Wouldn't SimpleDB be an option to that if you really care that you don't get it twice the same message or things like that? Because you still be in the same cloud, right?
Yeah.
I guess you have to logs. I don't know if you can do logs with
Well, so the question was, rather than using Amazon's SQS service, because you may not be guaranteed that the messages are going to come out in the order that you put them in, is could you use their SimpleDB service to do that? And so presumably you'd have some kind of key or identifier that you could get the messages out in the proper, or the data out in the proper order. And the answer to that is that from what I've read, and I haven't actually used Amazon SimpleDB service, is that it could potentially have the same problem where you put something in the database and it'll get there eventually, but it's not guaranteed that the next time you have a call to that database that it's going to be there. So you could run into the same possibilities that you're running into SQS in that regard. Yeah.
How do you pick out from the problem spaces that might seem given, what sort of problem space is a good candidate for EC2 or how do you decide, okay, this part of what I'm doing is something I should put on Amazon Web Services?
The question is basically, how do you decide whether or not you're going to use Amazon's web services for either your whole application or parts of your application? For me, that was pretty simple in the service that I built, is that rather than provisioning a whole bunch of servers to basically be able to handle a seasonal kind of load, I could have done that, but rather than doing that, I have parts of my application that aren't running on Amazon's web services, and the parts that I need to basically be able to dynamically scale without having to go through a provisioning kind of process on servers. That's where Amazon really had value there for me. And so I would say that the ideal kind of use case or candidate is that sort of thing where you have an application where you need to basically be able to scale up pretty quickly, and if you need the ability to be able to scale up dynamically, even more so. A lot of cases you could just manually fire up your instances, not have to worry about checking queues and that sort of thing to determine whether or not you needed more. But you could have a case where you're just going to get a couple, a high load for a day or two or something, just start up some additional services to handle the load and then manually turn them off when you need to. So I would say that those kinds of use cases where you basically need to be able to quickly bring up new instances and or shut them down quickly would be the use case for that.
So any sort of website might scale, you wouldn't necessarily separate out some of the functionality on the web services and some just stay on regular servers?
Well, no, I do that myself, where I have part of my application running on not Amazon's web service, just a server at a colo, because I need it running full time, and it's not something that I need to right now to be able to scale at all, because it's basically just doing simple database queries and things like that. That I'm not really hitting any kind of scalability issues in that regard. But on the other hand, with being able to run continuous integrations builds, if a whole bunch of developers check in a whole bunch of code at once or in a very short amount of time, the static server that I have sitting there won't necessarily be able to process those continuous integrations in a timely manner. And so it would be a simple thing for me to just fire up some EC2 servers, for an hour and basically chunk through all those continuous integration builds and then turn them off, as it needs to. So yeah, part of my application runs on just, static non-EC2 servers, and the other part, the part that I need to be able to scale, can run on EC2. EC2 just recently announced a day or two ago that they're adding static IP addresses to your instance. So basically, your account gets a reference to a static IP address that you can then assign to your instance. Because one of the big things about EC2 before this was that it just gets some random IP address somewhere, and so people were wanting to run their entire application, everything on EC2. Well, that's when I go to www.whatever.com, how does it get to your EC2 instance? Because the instance gets allocated a dynamic IP address. And so there are a lot of different workarounds for that, and dying DNS and those sorts of things. Well, Amazon just recently announced that you can have a static IP address now, so that when if you have an instance go down, which again, I'm not entirely sure how often that really happens. I would think, Amazon says that basically your instance can go down if, they have some kind of hardware failure or you manually shut it off. And those are pretty much the only two kinds of situations that would cause your instance to go down. But should it go down, you can basically start up another instance, and even start up another instance in maybe a different colo, their network operations center, and basically start up another instance, point your IP address to it, and basically it'll start using that. So, any other questions? Yeah.
Where do you keep your data?
Where do you? Well, in here I just kept it in a MySQL database.
Do the nodes communicate with that single MySQL database?
no, the instances don't communicate at all to the application server or the database, which is part of the reason why I chose to use SQS for basically doing in the service that I'm actually running for like the continuous integrations. Or, yeah. So what I did there is I mentioned earlier on the slides where you can only put so much data in as a message, and so you're pretty much going to be using like an identifier or like a file name for S3. So in my particular instance, what I'll do is I will go and upload the code to S3, get the file name for that, put the file name in SQS along with a couple additional pieces of information like what database to use for continuous integrations and that sort of thing. So the message is still really small. The instances have enough information to go and run the build. When it's done running the build, it will go and it will basically use part of that identifier from the first message, put that into basically a done queue, and will upload in a YAML file the results of the continuous integration build onto S3. Then I just have a process sitting on my application server, on my non-EC2 servers, that just go and pull that queue, go grab the file out of S3 to get the results, and then update the database there. Yeah, use basically S3 as a data transport for that. I could, getting the code to the instances would still be S3, but I could use like simple DB if I wanted to get the status of the build, just store that in there. I probably could do that, but unlike the SQS, the simple DB, I'm not entirely sure. It seems like there's a lot of different options that are starting to pop up out there that could basically do the same thing, maybe even better or easier. CouchDB, we're going to have a talk on that. You could probably use that. There's the stroke DB and those sorts of things where rather than the simple DB, you could use those sorts of things, because I think eventually it'll have authentication and those sorts of things so that you don't have to worry about setting that up. Like I said, with the SQS, if I wanted to spend the time to get authentication working so that my instances, regardless of where they're at, can communicate with my queue, then I'd probably go ahead and probably not use SQS anymore, because it does have issues you have to account for when you're using it. Cool. Well, so resources. You can actually get this application on GitHub, and it has all the code up there, the entire thing. Like I said, I've emulated EC2 for this, and so what that does is just basically a MERB app that responds to the API calls that the right-scale gems use, and basically uses God to load a config file for what my faux EC2 instance is, and does the processing that way. And then I've also got another MERB application that emulates the SQS queue. For this particular use case, because I needed things kind of real time, it's just hammering the heck out of the queue, doing multiple per second queue requests. In kind of a real life situation, rather than this kind of contrived example, you wouldn't be hitting your queue so fast, more than likely. And if you did, it's going to be kind of slow, because it's having to do an HTTP request over the network to Amazon, process that and get that back to you. And so that's not always a really performance critical kind of thing like I wanted to do here. So here I'm just monkey patching the right scale SQS gem to basically just talk to a local database instead of talking over HTTP. But I did put the MERB app up there that does emulate the parts that the app could have used if I didn't need it to be so performance critical. Well, thank you.